Welcome back, Physical Science 20. So this is the FC2.3 mass and number of particles section. So here we'll look at performing molar conversions, including mass to number of particles, and vice versa, using the correct number of significant figures, and calculate the number of atoms or ions in a particular sample or substance. So if we take a look at this, mass and number of particles, how many molecules of water are there in a drop? Even the smallest visible drop contains more molecules than you would ever be able to count in a lifetime. Because molecules are so small, chemists use mass as a convenient way to estimate the number of things. So again, using mass to count things. So for example, a chemist knows that water has a molar mass of 18 grams for every mole. Therefore, they know that if I had 18 grams of water molecules, you would have 1 mole. And 1 mole represents this many molecules, 6.02 times 10 to the 23rd. Similarly, if I had 36 grams of water, well, see, that's double of what 1 mole would be, so it would be 2 moles. Avogadro's constant, which is the number for Avogadro, serves as a link or bridge between the mass of the pure substance and the number of entities present. So determining the number of entities or things, we often use counting units to specify a number of entities. A dozen is a counting unit. It means 12 things. We can represent a larger number using dozens as the unit. For example, 5 dozens would have 60 donuts. And of course, to do that, we know that there's a conversion factor here. So we know that we have 1 dozen equals 12 things. Or we could arrange that as 1 dozen over 12. Or 12 things is 1 dozen. And of course, this version helps us here because dozens and dozens cancel and we're left with units of donuts. So in general, how many dozens we have, we multiply that by 12. And on the next page, similarly, you could talk about number of molecules of water is the same thing. So 5 moles of water, if we know that there's 6.02 times 10 to the 23rd things or molecules in the case of water, in 1 mole, then just simply multiply by that by 5, and we get 3.01 times 10 to the 24 molecules. A pure substance can consist of atoms, molecules, or ions, as we mentioned. So you need to be able to distinguish between the both. If we're dealing with a single element, we're talking about atoms. If we're dealing with groups of nonmetals that are bonded together, such as carbon dioxide, water, oxygen gas, we're talking about molecules. And if we're talking about ionic compounds, we could be talking about formula units, which break down into ions. To find the number of these particles in a sample of a substance, we first need to know the amount of substance, then we can find the number of particles. And by amount, I really mean moles, finding the number of moles. So if we take a look at this example, calculate the number of atoms in a 1,000 gram bar of gold. So figure out your given grams, figure out atoms, and of course here we're going to the representative particle of atoms. We're starting with grams, so we can see, yes, we need to find the amount, or in this case, moles. So we need to use that, and we need to use that. So of course, yes, we need to know the molar mass, because we're going from grams to moles, and then from there into atoms. So we need to find the molar mass of gold if we check that out on the periodic table. So there it is right there, AU 196.97. So 196.97 grams per every mole. So starting out with what we have, 1.00 times 10 to the 3 grams of gold. And of course, we know the different ways we can represent this factor as grams over moles or moles over grams. And that's in fact what we have to do here. 1 mole of AU is 196.97 grams of AU. And if you struggle with that, which one to put on top, it's set out here for you. So right now we would be right here. We'd be at moles. But of course we want to go one more step. 1 mole of gold represents 6.02 times 10 to the 23rd. Now we're just talking about gold by itself, so that is an atom. So atoms is what we're talking about for the representative particles. Cancel that out, and we would get in your calculator 3.056302999 times 10 to the 24. I'll just move my paper so we can see that edge. Atoms of gold. And of course here, if we look, we have 1, 2, 3 sig figs. So 1, 2, 3 sig figs. So this is going to get bumped up by 1. 3.06 times 10 to the 24 atoms of gold. Good, so that's how we do it. So it's a two-step conversion here. So you can see here in this first step, I'm going from grams to moles. And then from there, I'm going from moles to atoms. Just following that scheme right on that chart. All right, let's look at another example here. So we look at ammonia as a pungent gas released from smelling salts. Calculate the number of molecules when we have 4.00 times 10 to the negative 3 grams of ammonia. So you can see NH3, that is a molecular compound, so we're talking about molecules. So again, we have to do those two steps. And of course, the first step here is figuring out the molar mass of ammonia. So for every 1 mole of ammonia, we have 1 mole of nitrogen and 3 moles of hydrogen. So if I look at nitrogen, it's 14.01. Hydrogen is 1.01. So that's going to give us 17.03 grams per mole. 17.04. So we start off with grams. Start off with what we have. It's 4.00 times 10 to the minus 3 grams of ammonia. And then going from grams to moles. So again, where you're starting from goes on the bottom. Where you're going to goes on top. So we're going to be going from grams to moles. And in this case, grams of ammonia to moles of ammonia. And we use the molar mass. How much is in 1 mole? So if I was to stop here, I would end up with moles. So of course, I need to do one more step. Going from moles to molecules. Moles to molecules of ammonia. So 1 mole is 6.02 times 10 to the 23rd. So again, how many things is 1 mole? It's that huge number. So that gives us 1.413145 times 10 to the 20 molecules of ammonia. Okay, and of course sig figs. 1, 2, 3. 1, 2, 3. This is a 3, so that's going to stay as a 1. So 1.41 times 10 to the 20 molecules of ammonia. Good, so that's what we end up with. Let's look at the next one. Determine the number of ethylene molecules. So C2H4, that is a molecule. So we're going to be going for molecules. If you have 7.3 grams of ethylene. So why don't you pause the video, run through that, and then come back in the next video to see exactly how you do that. All right, so go ahead, try that, then tune into the next video. All right, we'll see you again.